So we've got the entire unit circle here, and I want to talk about the angles first. So when we talk about angles kind of rotating around this circle, you start right here every time. So when we say 0 degrees, so no rotation, you're just right here. So this is 0 degrees, and then if you rotate some positive angle, you're going to rotate counterclockwise this way from there. So 45 degrees would be this rotation here between these two, 45 degrees. All right, so we're rotating up this way for a positive angle. If you have a negative angle, you're rotating clockwise, so you go down from that spot, whatever amount the angle is. So the first thing to notice, there's a lot of information here, but focus first on the degree measurements all the way around. So we've got 30 degrees, 45, 60, all the way around in all 16 spots. You've got kind of your standard measure for those angles. So if we wanted to show, let's say 135 degrees, we would go right here to this yellow spot in the second quadrant. Your quadrants are 1, 2, 3, 4, if you ever need them. The other measure that is shown for these angles, aside from the coordinates, is the second thing listed here that all have pi in them. These are your radian measures for the same angles. So 30 degrees is the same rotation as pi over 6 radians. They're just different methods. So degrees just come from splitting your circle into 360 equal little pizza slices. That's just kind of what degrees are. Radians will actually show you the side length along the angle. So if this is the unit circle, that means that it's centered at the origin, so this is like the x and y axes, and it has a radius of 1, so this is 1. So as long as this is the unit circle, the length of this rounded path here is exactly pi over 6 in whatever units the xy plane we're actually in. So radians, people tend to not like them because they have the pi in them, but they actually physically make a lot more sense in terms of the unit circle. So if you have forgotten some of your radian measures, don't worry, you can always have this image in front of you. So you do want to remember that 2 pi radians is 1 full rotation. That's why 2 pi and 360 degrees are the same. And then everything is just broken up proportionally from there. So halfway to 2 pi is 1 pi, halfway to that is a half pi, and so on. Okay, so the third component kind of in each piece of information is this xy coordinates here. So for this first one at 30 degrees or pi over 6 radians, these are the xy coordinates of this point right here on the edge of the unit circle. So the x value of that point is root 3 over 2, and the y value is 1/2. And that tells us that the cosine of this angle is root 3 over 2, and the sine of this angle is 1/2. That's why in the corner up here it says cosine comma sine. The x value in each of these coordinates is the cosine of an angle that lands there, and the sine value of an angle that lands there would be the y value here. So, for example, if you wanted to compute, we'll kind of come down here, let's say the cosine of 150 degrees. Let's say you're asked for that value. You first want to find where 150 degrees is, which is right here. Then the cosine is going to be the x value of the point right there. So negative root 3 over 2 would be your answer. So that would also be the cosine of any angle that lands in that spot, right? So 150 plus 360, like loop around extra and still land in that spot, or if you rotate backwards and land there, your cosine would still be that number for the same reason. So you may be wondering why this is color-coded, and because we always have access to the unit circle in this class, memorizing the pattern isn't as important, but I do want you to see the pattern in it, even if you aren't relying on it to compute this semester. So look at just the pink highlighter first. So the pink is right here and right here. Just those 4 locations on the unit circle. So we have 4 different angles, 60, 120, 240, 300, okay. Now the coordinates of x and y, you got 1/2 root 3 over 2, 1/2 root 3 over 2, 1/2 root 3 over 2, and 1/2 root 3 over 2. So the only difference among these 4 points is where the minus signs are, right? Both positive, negative, positive, both negative, and then positive, negative. That's also the pattern in the 4 ones matched up in yellow. They all have these coordinates, and then just the minus signs change based on what quadrant you're in. And then same thing with the blues as well, which is why I have these extra images down here. So all 4 of the pink angles share coordinates with 60 degrees. And then you just decide, you know, okay, if it's down here, its sine and cosine are both negative. So you just kind of put negative signs where they should be. And then same thing here, they all have the same values as 45 degrees, give or take some minus signs. And then this one is 30 degrees. So if you need to have this entire image in your head for some reason in a different class or in a future job, it's actually not as much memorizing as it seems, because it's all about noticing the pattern in these 3 kind of bow ties. So 60, 45, and 30 are often called the reference angles, because if you know these 3 sets of coordinates, you can refer to them and get the coordinates for all the way around.